Hello and welcome everyone. Today we'll be building a dangerously smart AI. An AI so smart it can take any human request, transform it into Python code, review it for errors, and then safely execute it within a containerized environment. This AI learns, adapts, and executes the code in real time. This isn't just any AI, it's a dangerously smart agent powered by LangGraph, and we are about to unleash it. The magic behind this smart AI is LangGraph. So what makes LangGraph truly dangerous is its ability to handle complex multi-step operations dynamically. We get to use a StateGraph where each node in the workflow controls a critical function. So from understanding what the user is talking about, pre-processing the initial requests, and then converting it into a code. So performing code generation, code reviews, and then finally safely executing it into a Docker container. And all this is managed and controlled by a nice workflow structure that LangGraph provides us. So this isn't just a simple agent, it's an intelligent system that autonomously generates and verifies its own code. So this agent doesn't just create code, right? Like I said, it will evaluate it. It will improve upon its own output using a multi-phase approach. So it starts by pre-processing a request, and then the user request is sent to the code generation agent, which will perform a critical review of its own work. And then if any step fails over here, the agent can automatically go back, adjust its generation, and then try again. Only once the code is verified that it passes the standards, only then it gets executed in a Docker container. So you are always safe against the own potentially dangerous code that is generated, right? So the AI is dangerous, it still keeps your machine safe. It's a perfect blend of power and safety working in cycles until the code is fully optimized. Let's take a look how we develop a system like that. So in general, the similar kind of AI structure I've talked about in a previous video that I did, where you ask a question to a large language model, it gives you an answer. And if you want to make sure that your AI is not hallucinating, then you provide certain tools to the AI. For example, if you're asking for weather, then those weather tools are available to AI, and AI can make use of the weather tool. Then it can check whether it is hallucinating or not, and it can respond back. The problem is, what if the tool that you have provided to AI isn't sufficient? What if AI needs to come up with a new tool? How do we do that? In this video, I will answer this question. So when a user asks a question to AI that generate first 10 prime numbers, as an example, AI does not know that. It can try to do it. It can use its intelligence to generate prime numbers, but it cannot do it. But if there is a way for our AI to think through the whole process, utilize a very smart, intelligent, and dangerously smart AI agent over here, then it will not only come up with a solution, but it will come up with a very robust and secure solution for you. Let's see how we can do that. So in this example, we'll be having multiple agents working together in order to come up with a solution. So whenever you ask a question to this smart framework, that question, for example, if you have asked generate first 10 prime numbers, right? Or find square root of 144. And or a very complex mathematical question that the AI, even though as smart as it is, it won't be able to answer right away. So we may have asked a question in a convoluted way that normally the AI agent won't be able to translate into a code. So there are multiple agents working together, and you can see that we have built 5 agents over here that are working in conjunction to get this done. So this is a multi-agent framework that is the whole workflow of that is regulated by our LangGraph. So what are these 5 agents? So the very first agent that will come into picture is the prompt processor agent, right? So what is this prompt preprocessor agent? So whenever you ask a question to the AI model, that question won't directly be sent to the code generation agent. It will be sent through a prompt preprocessor agent, which will structure the prompt in an adequate way for your code generation agent. And once the prompt is structured for code generation agent to ingest, only then it will be passed along to the code generation agent, which will create the code for that prompt. And then there is a code extraction agent, which will extract the code from the prompt. There will be a code review agent coming into picture, which will review the extracted code, make sure that it passes the code review criteria. And if it does, then we'll be passing it along to a code execution agent, which will execute the final code for us, right? So let's fix some typos over here. All right. So in order for us to achieve this, let me show you how the whole structure will look like. So in this is the flowchart. On the center, you will see this is how the logical flowchart is structured over here. And on the right hand side, this is the LangGraph representation of the same logical flow. So we start by providing a prompt to the whole multi-agent framework. The prompt is getting pre-processed, and then the code is being generated from that pre-processed prompt, and then code is extracted from the pre-processed prompt. The generated code is extracted, and then we check whether the code is extracted correctly. If it is, it goes to the next step of code review. If it is not extracted adequately, we go back and regenerate the code, right? So code generation agent then goes back and regenerates the code. And then it goes back into the flow till the code is extracted correctly. So you'll see that the green arrows over here is the happy path, and the red arrow over here is the path where the code one way or the other needs to be regenerated. So if the code was extracted successfully, then the code review agent kicks in, and that will take a look at the code, make sure everything is fine, and it passes its own standards and criteria. And if it does, then it will send it for the next step, where it will check whether the code review is successful. So code review agent just generates the output for checking whether the code review is successful or not. And if it is successful, then it goes to the code execution agent, which executes the code into the Docker environment. But if the code review wasn't successful, if the criteria had failed, then we just send it back and we regenerate the code that, nope, this is not a good enough code for whatever reason. It needs to go back and we need to regenerate the code. So you will see how there are multiple loops over here. There are multiple loops that send the code back to the code generation agent and force us to regenerate the code if the code either has not been extracted correctly or if it has not met the review criteria. And once you have met all the criteria and then you go to the green path, happy path, do the code execution, then you come to an end over here. And this is the exact same thing that you can see in the LangGraph, but I do not like the LangGraph representation of these flows. It is nice that they provide us a way to view it, but it just doesn't look as pretty. So this is the LangGraph representation. This is my own representation over here of the logical flow. All right, so in order for us to do that, we'll be maintaining an agent state. So what is an agent state? Agent state is a state that can be passed along while you are having a flow, a workflow in your application, in your multi-agent application. So for example, at the very start, there will be just an initial request. And then as you proceed into your flow, various parts of the agent state will be populated. So this is your agent state over here, which is going to be populated while you have progressed into your workflow. Let's take a look at the code now and see how this looks like. So before I do that, I'm just gonna execute the code once so you can take a look at what our code essentially will look like. So you can correlate it when we are actually executing and looking at the code. You can correlate the methods and functions and how things are working. So let me just execute the very first code over here, which is workflow. And what it does is on the left hand side, you'll see that, okay, perfect. So our very first example failed over here. Let me go ahead and make sure that I have set my agents to point to the correct AI server. So mine is ai.mtcl.lan and it is routed at 11436. Perfect. So you of course will have to make sure that yours is localhost :11434. In my case, my Olama server is at a different port, and that is a different server and different port, and that's why it is asking me to change that. Okay, so we'll execute this code again, and you will see that on the left hand side, this is my AI server over here, and over here you will see that the large language model will be loaded over here on these two servers, which is what I'm using. This is the 11436, and on the right hand side the actual code execution will continue. So we have asked to calculate the factorial of 10, and I will scroll over here so you can see. So initial request, calculate the factorial of 10, and preprocessor agent result was generate Python code to calculate the factorial of 10 using recursion or iteration, right? So if we go back over here and see that we have a preprocessor agent already kicking in, and it is generating a nicer prompt over here. Now let's go down. Once the preprocessor agent is done, right, and we go to the code generation agent, then I'm printing the agent state all over again. So this is the state, and this is the generated code that came out of it. And in the next section, we go and agent extract code state, right? So we are extracting the code from the generated prompt, and this is the extracted code over here. Now we'll go into the code review phase, and in the code review phase, we'll see that the code review result is correct. The code, and this is the message that the code review agent has passed along. The code correctly calculates the factorial of a number. It does not contain backticks or markdown syntax and is fully executable. And it solves the initial request. Right, so the status over here is continue because the code review is correct, and then we continue over here, and you'll see that the final step over here is running the code in Docker, and the code was run in the Docker environment, and it executed the final output over here, and you get the final result of 362.8800, which I believe is the factorial of 10 over here. Okay, so how did this happen? How did the code, the multi-agent environment walk through this workflow? And this is what I'm going to show you now. So let's take a look over here. And let me stop this also. I'm going to Control C and stop this, so you will have a look over here in the code. So let me come over here. All right, so the code starts with this workflow LangGraph dynamic agent, right? So this is the place where we are creating our workflow. So in our workflow, there are various nodes, and then there are various conditional edges. And so the step number one is that we need to define all the nodes and all the conditional edges so that we can hook all those things together, right? So we can wire the whole LangGraph framework together. And in order for us to do that, we need to first define all the nodes and all the edges. So in our case, let's take a look again. In our case, the nodes that we have are 1, 2, 3, 4, 5. We have 5 nodes over here. prompt preprocessor agent, code generation agent, extract code from generated prompt, code review agent, and code execution agent. We have 5 different nodes over here. And we have 2 conditional edges over here, right? So one conditional node edge is over here, and second conditional edge is over here. So the difference between conditional versus a regular node is that a node only goes from point A to point B, right? So there is just one arrow that it goes, and only one outward arrow from a node you will see, right? So it can have multiple incoming arrows too, right? It can have multiple incoming flows. A node can do that, but there can only be one outgoing flow for a node, right? So this is also a node because there is only one outgoing flow. Now, a conditional edge is something where you will have at the least 2. I mean, you can choose to have 1, but you will normally have 2 or more outgoing arrows over here. So based on the condition, you'll have 2 or more. So in this case, if the code is extracted correctly, and if it says continue, so I've not shown the word continue over here, but this says continue, and it goes to the next block. If it says regenerate, then it goes to the code generation agent block. So how many nodes do we have? 1, 2, 3, 4, and 5. And how many conditional edges? 1 and 2. So there will be total of 7 functions that we will define in our code over here. And let's visualize that. So we have a total of 1, 2, 3, 4, 5. These are the 5 nodes, and 2 conditional edges, which are 1 conditional edge and 2 second conditional edge over here, right? So there are 5 nodes and 2 conditional edges that we want to make sure that we have over here. Let's define these 5 different conditional edges and nodes, and then come back over here and take a look at how this whole workflow is set up, what is an entry point, what is an edge, and all those things we will see too. So these 5 nodes and conditional edges I have described, or I have written in agents.py file over here, right? So I have made this code modular so that you can also modify this flow based on what you would like to do. So if you now move to agents.py file over here, you will see that all these 5 different, or actually 1, 2, 3, 4, 5, 6, 7, all 7 different agents and conditional edges are all defined over here. So let's go back and take a look again so that we can refresh our memory. 1, 2, 3, 4, 5, 6, and 7. All these 7 agents and conditional edges are right here. Okay. All that being said, let's go to the agent preprocessor and see what does the preprocessor agent do. So all these preprocessor, or all these agents, are divided into 3 high-level categories. So let me go back to the diagram and I'll talk about it then. So all these agents that are in green color, right? These green color agents are AI agents. And an AI agent is something that will require a large language model interaction in it. Okay? The purple, the conditionals, may also require a large language model interaction over here. The blue ones, the blue one over here is a Docker agent that does not require a large language model interaction, but it knows how to execute a code, a Python code. And the orange one over here, it uses some Python function to extract the code, the code from the generated prompt, right? So we'll see how we are doing all these things, but at a high level, there are 3 kinds of agent. 1, AI agent, 2, Docker agent, and 3, Python agent, right? So we'll now take a look at that over here in the code. So if you see the very first agent preprocessor, it is using the lang chains invoke method over here. What is that? So in order for me to explain that, let me scroll up over here and talk about a little bit of LangChain, and then we can come back to LangGraph. So LangChain makes things quite easy for us when we are doing large language model interactions. So instead of us making a connection and using the requests library and directly using our request to Ollama server, what we are doing is we are delegating all that work to this LangChain framework, and we are utilizing something called Ollama functions. And this was actually an experimental feature in Ollama, in LangChain, and I think they have deprecated it now. But I absolutely love the effectiveness of Ollama functions. It is really, really awesome. So I don't know why they deprecated it. I still like it. I'm still gonna use it, even though there are newer ways now for using chat Ollama and all that. But I will see if I'll want to change the code for it. But Ollama function works amazingly, right? There's something with Ollama functions and Llama 3.1 models that it absolutely loves it. Anyway, so I'm going to be using Ollama functions over here. You can choose to use whatever you would like, but using Ollama functions, you can define your model, your base URL, and your format JSON. And then this would be your model that you'll be working with. Now, LangChain provides you with structured output generation and with normal code, normal chat completions. Right, so we're going to be using both over here. So for preprocessor model, where you are just taking a request in and you are converting it into a processed request for next step, you do not require a structured output over here. So we are just taking the normal human language and we are converting it into a more structured question for the next. So we do not require a structured output for this case. Same thing with code generation model. We are just asking the model to generate code. We are not looking for any special pydantic schema that we want our model to adhere to. However, when we are doing the code review, in the code review, we want a very structured output. What we want is the model to respond back in something called code review result output. What is that? So let's take a look at models.py, and over here you will see there is a code review result, where what we are doing is we are making sure that when the large language model responds back to us, it has the response in this structure, right? So the first message would be a result, which will be a string, but it will either be correct or incorrect, right? So it has like a kind of like a Boolean, but with correct or incorrect response over here. So if the code review has passed, then I'm saying that it is a correct code. If it has not passed, then it is incorrect code. And then the message is any message that the code review agent felt obligatory to send. And you will see what that means in a few seconds when I show you the prompts.py file. But I want to show you that you can force a large language model to respond back in a particular way by enforcing the pydantic schema and utilizing our, let's take a look over here again, and utilizing our model with structured output. Right, so we have now three different models that we have with us. First two models are exactly same simple models that we have from Ollama functions, and the second one we have Ollama functions with structured output. And whenever the model will respond back, when you do an invoke on this, then it will be forced to respond back with the code review result as an output. So once we have initialized our models, then we create our something called generator, right? So these generators are that you take a prompt template and you pipe it with this model. So now the concept of the prompt template comes into picture. So let's dive into it. So we have several prompts created over here, right? So you'll see that we covered the workflow LangGraph dynamic. From here, we got into agents.py, and from agents.py, now we are going deeper into prompts.py. So let's take a look at prompts.py. So in prompts.py, you will see there are three different prompts. So let me minimize them and then I'll open them one by one. There are three different prompts over here. First prompt is the prompt that guides the large language model to process the initial request into a Python code generation request. So whenever we are working with the local models, right? So like Llama 3.1 or 3.2, whenever we are working with local models, the problem is that they need a lot of hand-holding and guidance. So you need to provide few short templates over here. You need to provide some examples. But if you have a GPT-4o, a Claude models, right? So they are very smart models. Even Gemini works very good too. But if you're working locally with your local models, of course, you need to do a lot of hand holding, and you need to explain a lot of things to the model so that it does respond in a particular way. And that's where the prompt engineering comes into picture. It took me a while to structure these prompts in this way, but I think I've gotten to a point where these prompts are very robust and they are generating results the way I want them to. For example, in the preprocessor prompt, I've asked the agent and let it know that it is a preprocessor agent and its goal is to take users' natural language and refine it into a structured, actionable task. And these are the requirements for it. And if you spell it out very clearly, some good large language models, open source ones, do follow it. So I've asked it that, hey, you must return a concise task description that can directly guide a Python code generator, which is its next step. Do not include any explanation, natural language responses. Don't be conversational. Don't be chatty is what I'm asking it to do. And ensure that the output task is specific, executable, and clearly aligned with user's request, right? So all those things, I've given it very concise instructions to follow. And there are some few short examples after that. Hey, user request is, what is the system time? Then you have to respond with generate Python code to get the current system time using the time library, right? Or how do I calculate square root of a number? Generate Python code to calculate the square root of the number using math library. So there are some requests that I have, examples that I have provided over here as user requests, and also samples that the AI should respond back. And then there is a user request over here. And based on this, AI is supposed to now respond back with the output. So this is the whole concept of crafting a prompt where not only you give it instruction, right? You also provide some few short examples so AI can take a look and then respond back in a more meaningful and intelligent way. Okay, while we are here, let's take a look at some other prompts that are in the same file. So this was the preprocessor prompt. So this preprocessor prompt gets passed on to the code generation agent eventually, and code generation agent also has some specific prompts provided to it. So in the code generation agent, I've provided it that you are a Python code generation agent. Your goal is to generate fully executable Python code based on the given task. And then these are the requirements that it needs to include all necessary imports, functions, and main logic. It can only return the Python code wrapped in triple backticks. But I've noticed that I did not want the word Python in here, like triple backticks and Python, because that was kind of messing up with my down the line applications. So I very specifically asked the model to only have the code wrapped in the triple backticks. Do not include the word Python right after that. And also no single backticks, only triple backticks should be used, because I've noticed that the model was kind of using just the single backticks without these two, and it was not following the instructions very clearly. So there is a very specific line guiding it not to do that. The response should only be the code, no explanations, no comments, alternate solutions, or unnecessary new line side. Just give me the code is what I'm asking it to do. And the code should be concise, correct, and optimized for readability and all that. So all this is done, and then there are some few short examples that generate a Python code to get the current time using the time library. So this is one of the inputs that it will get from the preprocessor prompt, right? And this is how it will convert and get the code for us. So this is the code generation prompt template, and now code review prompt, and this is very interesting, right? So code review prompt comes into picture when the code extraction has already happened. So code extraction extracts all the code from the code generation prompts results, and it passes it on to code review. In code review, I have two criteria. Criteria one is to make sure it is just Python code, right? There are no backticks, there is no explanation, nothing else. The format should be correct. So it needs to make sure that it is an executable, fully executable code. So that is first criteria. The second criteria is that it needs to solve the original user's request, right? So not only the criteria is that it should be a good code, but also it needs to solve the original request from the user, which is very important in our case. Okay, so there are some few short examples. Calculate the sum of two numbers, and if this is the code, then it will respond back with comment as correct and message as correctly calculates the sum of two numbers, right? So this is a positive comment over here. Now there is a second example, multiply two numbers and def multiply AB, and then you see that this particular one has an syntax error over here. So there is an indentation error on line 2, so it is commenting this out. So these are just some examples that I have collected and provided to the code over here, to the prompt over here. For example, this one, it says, hey, this is the code. So sometimes my code extraction agent was not working good and it wasn't able to extract the code correctly. So if this happens, then backticks are detected and this is not allowed. Markdown formatting is not allowed over here. So this is an incorrect code. And then calculate factorial of a number. And then over here, it says the code does not appear to solve the initial request because it is not factorial. It is just adding the two numbers. So even if the code is structurally and executable, it doesn't mean that it will let the code go. Not only will it check for the formatting, it will also check for the initial request with the logic that is being produced over here. So what are the two things that we need to pass to this particular prompt? Generated code and initial request, both. So generated code from the previous code extraction agent, and the initial request is the one that was requested for it to do. All right, now that we have covered the prompts.py, let's go back to where we came from, which is the agents.py. Okay, so in agents.py, you will see that preprocessor agent generator used the prompt template from the preprocessor prompt, right? And then we are using the preprocessor model, which is just a simple model over here without it being the pydantic schema, because pydantic one is over here. Now, the agent code generator uses a different prompt, the code generation prompt from the prompts, and it uses the code generator model, which is the same model over here. Now, the third one, the code review agent generator, it uses the code review prompt that we just took a look at, and it uses the model that is bound to a pydantic schema. So this will return only the code review result and nothing else. All right, so all that being said, now let's go back to our main view and then correlate what we are going to take a look at next. So we've seen how these models, so 1, 2, and 3, these 3 green models, we've seen how they needed a prompt template to work with. And each one of these have their own prompt templates. We've also seen that the code review agent has a very specific output type, which is a pydantic schema. It's a code review results pydantic schema, which has whether it should continue or not, so code review status, and also it has the message, right? So the comment, whether if the code review has passed, then why, if it has failed, then why, kind of thing. So there are 2 very specific components in that pydantic schema that are getting out. Okay, so now that we have these 3 agents, let's take a look at how they are implemented over here. So the very first agent is the agent preprocessor. So the way we implement it is we pass the agent state to all of these functions. So agent preprocessor will take in a state and it will output the same state back, and we will modify the state within this particular method. So agent preprocessor is going to take in the state. In the state, we extract the initial request and we pass it to the preprocessor agent generator.invoke method, right? So in this preprocessor agent generator.invoke, you know that the user request is being passed. How do you know that? So let's follow backwards. Preprocessor agent generator is right here. It uses preprocessor prompt template. In the prompt template, if I open this, you will see that there is only one input, which is user request, right? So this is the user request, and this is how you know that you are going to pass in the invoke a user request. And so the user request is the value that will be passed. What is the actual value? User request is the key that will be passed. What is the actual value of the user request? The actual value is in the state. So whenever we pass in the state, we always populate the initial request, and this being the entry point, it will take in the initial request part of it, assign it to the user request, and then do a invoke on it. And this is how you'll get the final result from here. And the result from this particular output will be assigned to the state object's preprocessor agent result, right? So we are going to take in the state that did not have the preprocessor agent result. We will calculate the preprocessor agent result and then assign it to the state, right? So let's take a look over here again, it will make sense. So when we first bring in the state, initial request is populated. Initial request is used by the prompt preprocessor agent. And while you have processed this, the prompt preprocessor agent then updates the preprocessor agent result within the agent state. So this is how, while you are progressing through this whole flow, you will see how every element is being populated. So everything else right now is empty. Only the preprocessor agent result is populated because this just got the chance to execute. So that's how you take in the whole agent state as an input, and you keep on populating whatever you want to populate as an output. Now that being said, this does not mean that if you have like a big huge agent state, does it mean that you're using a lot of input tokens? No, absolutely not. And this is where LangGraph shines. So even though you are passing in a huge agent state, let's say, you can choose which part of the agent state needs to be in the input tokens for your large language model. Like in our case, we only had the initial request as the input token of the large language model for prompt preprocessor agent, and the prompt preprocessor agent is going to populate the preprocessor agent result over here. And then in the code generation agent, you will see that we will take the preprocessor agent result and pass this. Even though initial request exists, we are not going to pass that. So only whatever we want to pick and choose from the agent state will be passed along to the next agent. Let's take a look how that's happening. So now let me close this. In the code generation agent, you'll see that we are doing an invoke on a task right? So this, how do you know that you need to pass task over here? You know by following backwards. You go to agent code generator, and agent code generator takes the code generation prompt template. Code generation prompt template, if we take a look over here, this will take a input of task, right? So in your invoke, you will do task colon whatever. So the key will be task, and the value is going to be, let's take a look, not this one, sorry. Let's go back to our agents. So you will see that the key is task and the value is the preprocessor agent result, right? So the value is the preprocessor agent result. So this is going to take the key as task because in the prompt template, we have defined that as a task, and the value is whatever is in the agent's state because it has already been progressed and went to the next step over here. All right. So once you get the value back from here, you now populate the generated code result in the state. So you take the value from here, from the results.content, and you populate it in the state, and then you move on to the next phase over here. So I'm going to close these two right here. So generated code result is also populated by agent code generation over here, and I'm going to close this. And now we are going to extract the code, and this is really interesting. So many times when we were generating the code, even though we have instructed the model to generate the code in a very specific way, only 3 backticks or without the word Python, but model really kind of gave up many times. So what I've done is I have 3 different regular expressions that we will work with. The very first regular expression is where we do not have the word Python, right? So we do not have the word Python after the 3 backticks, and this is our happy path. So very first is you extract the whole code and you do not have the word Python, and that works. The second is if, let's say, the word Python was written by our large language model, all right, we will still give it a pass, and we will use this second regular expression where we can extract even when the Python is in our response from the large language model. And the third one is if there is a single backtick, because this was also like 10% of the time the model was doing it, then fine, we'll extract that also and we will move forward. And sometimes I've noticed that the large language model response, the agent code generation response, was coming back directly as just the code. So if it is that, then we will accept just the code over here as a response, and then we will continue. But don't worry, whatever code that we have extracted, right? So let's say we have extracted a piece of code. We will check whether the extracted code is correct, and then we will proceed, right? So there is a check over here to validate whether the extracted code is correct or not, and that is what we're going to take a look next. So let me close this section, and conditional should continue after extraction, right? So this is the first conditional block that we will take a look at. And should we continue after extraction? It says continue or regenerate, and only if this passes through. So whether our code is extracted correctly, that is stored in the code review code extraction status, and if it is extracted correctly, then only then we go to the next phase over here. So you'll notice that in the previous extract code method, we had put the code extraction status as continue if the extraction was successful, and if the extraction was not successful, we have set the code extraction status as regenerate in our agent state, right? So if we come back over here in the agent state, code extraction status was set as either continue or regenerate. So if the code extraction failed, then we're gonna regenerate it over here. But let's say the code extraction succeeded, right? I mean, what if the code was successfully extracted, but it is not not even Python code, if it is just the large language model just talking to us for whatever reason, then we'll do some more logic in code review agent, and which will use a large language model over here in order to make some decisions. Let's take a look at that now. So let me close the code extraction agent over here, and should continue after extraction. Let me close this too, conditional edge. And let's come to code review agent, and this is interesting. So this is where you'll see that we get the result back in the pydantic schema. So code review result we get back over here. And what we are saying is that, hey, go ahead, invoke the code review agent generator, and there are two things that need to be passed over here, right? There are two key values over here. So generated code and initial request, and we are going to extract the generated code and initial request from the state and pass it along to the code review generator, and we'll get the final result from the code review generator from it. Once we get the final result, we check that whether the response over here, code review result, is of type code review result, which is the pydantic schema. And it has to be, because this is where the LangChain framework comes into picture. It has enforced this schema so that it will get the results correctly. All right, so it checks whether it is the code review result, and if it is, it sets the code review result as code review result, right? So there is this particular state, code review result. This is set by the code review agent if the pydantic schema was successfully sent back by the large language model, right? So we get that, and if the validation has failed, and if it is not, like if something bad has happened in here, then we will say that nope, regenerate. If there is any validation error, we regenerate. If there is any exception, we regenerate the code. But otherwise, if everything has gone successfully, and how do we know everything has gone successfully? Because while doing the code review.invoke, not only do we have the final result back from the code review agent, but we also have the values that why the code review agent thought that this code is passing, right? So if it says correct, then we set the status as continue. If it says anything else except for correct, the code review agent, if it says anything else except for correct, then we say, okay, nope, regenerate the code, right? So this is where we are populating the code review status as either continue or regenerate. So if the code review is successful, then we continue, otherwise we regenerate. And this is what you will see next in the next section over here. So conditional should continue after code review. If you open this up, as simple as that, we take a look at state. So you will see that all of these are having states passed in, but the conditional edges do not output the state. Conditional edges output exactly where we want to send our code back, right? So we return continue or regenerate from the conditional edges, and we return the actual state, right? So we return the actual state from the non-conditional edges and regular nodes, right? So one second, 1, 2, 3, these three agents will return state. This agent will return state, and this agent will also return state. And all these conditional edges will not return state, but they will return exactly where we want to send our route to. So there are two routes over here for the conditional nodes, edges. Either you should continue, which is the happy path of green, or you should regenerate, which is the red path, right? So it should regenerate whenever we get the regenerate out of it. Let's take a look again. So anytime when the conditional edge says regenerate, we route it back over here. When it says regenerate, we route it back over here. And how this regenerate is mapped, I'll show you 1 second once we take a look at the workflow again. All right, so now that all this is done, right? So we have been able to do all this. I'm gonna save the execute code in Docker. I'll save the description and the definition of that for just a little bit more, but let me just go to the workflow LangGraph dynamic agent, this particular one, and you will see how everything is wired. So we added the 5 nodes. So you just go ahead and add these 5 nodes. You set the entry point to the very first node, right? So entry point is set. Then we add the edges. So the edges are, so let me show you over here. So you see there is the first edge, agent preprocessor to agent code generation. What does this mean? This means that there is a direct connection from agent preprocessor to agent code generation, right? It's a straight arrow. There is no condition over here. From this edge to this edge, you go directly. Again, let's go back. Agent code generation to agent extract code is a direct edge, right? There is no condition over here. Let's take a look again. Agent code generation to agent code generated prompt, extract generated prompt, direct edge over here. However, as soon as you come from here to this condition, now things will change. So from this particular agent to this conditional edge, things will change. And let's take a look over here. So now we are going to add from agent extracted code to the conditional edge. And from this conditional edge, it can go either with the continue response, it can go to the agent code review, or with the regenerate response, it can go to the agent code generation. And that is why the conditional edge of this particular conditional should continue after extraction was returning either continue or regenerate. And this was not returning the agent state. Let me show you again what I'm talking about. So this conditional edge was returning continue or regenerate. Again, this conditional edge was returning continue or regenerate. And based on the output of this, you will route your flow to the next node, right? So let's go back to the workflow, and you will see that starting node is this agent extract code, ending node is this conditional edge, right? So starting node is agent extract code, ending node is this one, and this conditional node then says, hey, is it regenerate? So can I route it over here, or is it continue, or can I pass it along over here at the bottom? So that is one important point that I wanted to show you, that conditional edges are written like this, with the starting edge and the ending edge, and the starting node and the end node. And the end node itself are multiple nodes based on whatever condition this particular conditional edge is returning. Same story with the second conditional edge for agent review code, that whatever this is the starting node, and whatever is being returned by should continue after code review. If it is continue, then you can go to the Docker. If it is regenerate, then you can go back over here. All right, so once we go to the Docker agent, we come to an end essentially. So what is in the Docker agent? And I wanted to save this for later, because the AI in our case doesn't just stop generating the code, right? So we haven't stopped ourselves over here. Let me minimize all this so I can show you what's happening. All right, very simple code, but I want to explain this. So the AI dynamically executes the Python code in a Docker container. And Docker plays a critical role over here because it provides an isolated environment for the execution of this code that AI has generated, right? So even if the generated code contains errors or it is potentially harmful and all that, our code review agent has taken care of it, and it has removed its execution criteria and all that, right? I mean, you can build in some harmful code error criteria as well in the code review if you would like. But let's say if all those got bypassed and somehow the code went to the next stage, you do not want to run it in your local machine directly. Any AI generated code, if it is autonomously running, with a scripting language like Python that has full control of your system, I will never run this. So you use Docker to make sure that your main machine remains unaffected. You minimize the damage that AI can cause. So this is where the dangerous aspect becomes more intriguing. The AI has the autonomy to generate unknown code, but Docker acts as a safety net over here, isolating any risks. So all these checks and balances that I have built in was to make sure that the generated code from AI doesn't get directly executed in our machine. So let's dive into the execution phase of this AI agent. So once the Python code is generated and reviewed, now it's time to run it. But we have to run it with caution. Like I said, the agent doesn't execute the code directly on your machine, but it uses Docker, right? So the containerization tool for safely executing the code in the isolated environment. So how does this work? So it works by creating a temporary file first. So the function starts by writing the Python code into a temporary file using Python's temp file module. And I wanted to make sure that everything is temporary and gets deleted at the end, and you will see how that's happening. So this temporary file is crucial because Docker requires a physical file to run inside its container. And we create this file with a .py extension so that Docker recognizes it as a Python script and then executes it accordingly. So we initialize the Docker client using docker.from environment._env. And this allows us to interact with the Docker from within our Python code. And you'll also see that in the requirements, I have added this Docker dependency over here, and you will need to run pip install requirements R for that, right? So that takes care of that. Now, running the code in the Docker container is the next step that we need to do. And that's where this particular try-catch block that you will see comes into picture. And what is happening here is that we instruct the Docker to run the Python code inside the lightweight Python 3.9 container. You can choose a higher version too. I just picked any random one, the slim container over here. And the parameters that we pass include the name, the image name. So in this case, Python 3.9 slim. We can use a higher version too over here. And the command to run the Python script is also passed over here. And the necessary volume bindings to make the temporary file available inside this Docker container. Now, error handling always needs to be done. So if the Docker container encounters any errors while running the code, we catch those errors using the Docker errors container error and print a helpful message that can be passed along to the user. And this ensures that we know exactly if the code fails, we know exactly why it failed. And we can also build upon our current agent where it can evaluate whatever the error was and pass it along to the code generation agent that, hey, this is the error that we got last time around. This is the code that you have originally generated. Now, can you fix this code based on this error? And we can build upon this use case also in future. And then at the end, we do a cleanup. And while doing the cleanup, we do a os.remove, of course, and we remove the temporary file name that was created over there. Okay, so by running the code in a Docker container, we ensure that even the most dangerous or erroneous code that has been generated by AI, it does not harm our system. And I cannot focus enough on this particular aspect. If you have a code that is generated by AI, do not, without any scrutiny and review, run it directly on your machine. Docker provides a safe sandbox environment. Use it. It allows us to explore the full potential of this smart agent without worrying about our system safety. It is a dangerous agent, and we want to minimize the danger as much as we can. All right. So after all that being said, now let me go back to this workflow again. So what we are doing at the end of this workflow is we run the code in the Docker, we end it, and once the code is ended, we do the workflow, the compile, and then this is a small helper method that prints our whole workflow, right? So it takes this particular workflow and it prints it into a PNG file over here. So if you see, this is the workflow that gets generated. And I don't like it. It isn't as pretty, but it is good enough. It shows us that we do not have any logical, errors in our code. And it kind of makes sense in that way. So once we have our workflow compiled, this is something for fun that I had done. these are a bunch of different kinds of prompts that I have created in an array. Right? And then I'm going to loop through all of these prompts, and we will see whether our code works good for each and every prompt or not, right? So we can see like there are diverse kind of prompts over here. So for example, write a Python code to encrypt and decrypt message using a cipher with a shift of 3, right? So will it be able to do it or not, right? Or if you see there is, I remember there was a prompt that I wrote that, hey, create a bunch of files that start with, this one. This was very interesting. Generate a Python code to create a bunch of files with the name starting with A underscore and M underscore, and then delete only the files that start with M, and then list down all the files, right? So it is a fun different prompts over here. And the way you can run this is actually just run this workflow file. It iterates over all these prompts one by one, and it prints it out too. So I've also created a utils.py over here. In this utils.py, there is a pretty print of the state. So at any point of time, if you want to print the agent state, just include this particular util and pretty print the agent state by passing just the agent state to this method, right? So you will see in the agents.py at multiple touch points, actually at the end mostly, I have pretty printed this particular agent state. And before printing it, I have printed also where this agent state is coming from, right? So it says agent execute code in Docker state, right? So agent execute code in Docker state, and then I'm actually printing the state value. So you can go ahead, modify the internals of the agent state, and then you can print the agent state also. So let's go ahead. Now is the time we can see what happens once we run the model. So I'm gonna run this model now, and it's going to take the very first request, right? So it is pre-processing the very first user request, and it said it cannot. So there's, I want to show you this thing. I'm glad this happened over here. So you see how we have, let's go to the workflow. So in the workflow, you see how we are iterating over each and every request. Right? So we are iterating over every request, and there's a try catch block over here. So if let's say you get a bad response from the large language model. So in this case, our Llama 3.170B just outputted, it just bombed. It gave us a bad response. So it catches that, and it will move on to the next prompt. Even though it is capable, if I rerun this model, this program, it will do it, but at least it will catch right now and it will move on to the next prompt. We can build in these checks and balances and make the code go back to the initial phase. So the reason why this is happening like this is because once we get, let me show you this. Once we get the very first prompt preprocessor agents request, we are directly going to the next request over here. If we do a try catch over here, and if it doesn't work, we can reroute it back over here to the prompts preprocessor agent. But it's unnecessary for now. But I'm glad that it happened because I could talk about it. I'm going to move on to the next prompt. So instead of calculating the factorial, I'm going to move on to the next prompt. So the next prompt is generate Python code to get the square root of 144. It generated the code. So you see how it has 3 backticks in the generated code. Then it extracted the code. Then the code review agent came into picture, and code review agent said that the code is correct. Code correctly calculates the square root of a number. It does not contain backticks or markdown. It's fully executable, and it solves the initial request. Awesome. And then the final output was 12, and the final result was 12 at the very end. Let's hit enter. Let's go to the next prompt. The next prompt is create a function that returns the Fibonacci series. And again, we got an empty response from the large language model. All right. Let's go to the next one. So over here, generate Python code to reverse a given string using the slicing or the reverse function. So it's gonna do that. And it is correct, and it did the reverse string over here for us. Awesome. Okay, let's go to the next one. The next prompt is to convert Celsius to Fahrenheit. This is interesting. Let's see. So it came up with a code for it, and it is reviewing the code right now. It said everything is good, and it converted Celsius to Fahrenheit. That's awesome. Let's go to the next request and create a function that checks if a number is prime, and our code bombed over here too. So this is actually not the problem with the code. I think we can add another check in a future video to make sure that the prompt preprocessor agent actually returns the request back. Okay, so let's go to the next request, and it is generate a function that calculates the area of a circle given the radius. So it got the area of the circle, it created a code for it, code review was good, and we got the answer back. Okay, let's do a couple more. I want to go to the point where we can do some file system requests. So perfect, merge code to write code to merge two dictionaries. So this is awesome. Oh, perfect. See, this is a perfect example. So while it was trying to write code to merge two dictionaries, it out of nowhere hallucinated and created a square root code, right? This doesn't make any sense. So the code review agent caught it, and it said that, hey, this code does not solve the initial request. It calculates the square root of a problem. So now we will go back to the rerouting, and rerouting will send it back, and it will say, yep, no, redo it, buddy, you did it wrong. And second time around, it went in and it created the right code, but still it looks like it didn't pass the code review criteria. It calculates the square root, so it didn't pass the code review criteria. It messed up again, and it messed up again, looks like, for whatever reason. And after a little while, once the code review said, yep, you are fine, it was able to make it pass through. So this is pretty cool. This is pretty cool that the code wasn't accepted unless and until it was reviewed by the code review agent over here. That is so awesome. So it self-corrected. I really like the fact that it did not let the code go through till it found out that the code meets all the necessary guidelines. Okay, let's hit enter to go to the next request. And this is where create a function to check if the string is palindrome, is bombing out. We're going to go to the next request. Python code to implement a binary search in a sorted array. Yeah, that's interesting. Let's have it do that. So it's going to generate its code. Code review is being done, and code review is successful. So we'll go to the next one, and there we go. All right. We were able to search that the fifth element over here is 1, 2, 3, 4, 5. Yep. So the target is 23. 1, 2, 3, 0, 1, 2, 3, 4, 5. So it is coming up with the 5 as an answer. All right. I'll do one more, and then I think we'll call it. So quadratic equation using the quadratic formula. It came up with the code for it, and it's reviewing the Python code. It is correct, and this is the result. I really want to come to the point where we have write a file. This is fun. Python code to create a file, add a poem in it, and print its contents line by line. Awesome. Let's do that. Create a file. Roses are red, violets are blue, Python is fun, and so are you. That's the poem it came up with. Okay. All right. And it will print the contents of it line by line. Provide code is correct. Creates the file. And read and print the file name. However, it did not show us as the final output because this is not a return from here. It is printed it in the Docker's console. This is all right. This is fine. Okay. And all right. The last one, I promise this is absolutely last one. This is the one I was waiting for, to generate the code to create a bunch of files with the name starting with A and M, and then delete only the files that start with M, and then list the files that start with A. So it came up with the code over here. It's reviewing the code. Incorrect. Okay. It starts with A and M and deletes only the file with M, but lists both types. Any filtering in the last step. Okay, so it did not pass its criteria, so it has failed it. So let's have it regenerate. It regenerated the code, and it is incorrect again because create and delete doesn't do what it's supposed to do. Okay. And now it generated again. Okay, the last one that it generated, it correctly creates, and the files with A and the files with M, which is what we want. The files with M are 0 because it has deleted all the files that start with M, and all the files that start with A are still here. So, all right, I'm gonna stop now. This is a really, really fun and dangerous, absolutely dangerous AI agent that can do a lot. My future goal with this agent is to give it some internet access, get some data from online, make self-correcting programs that it can review from online analysis, and then come up with dynamic code. All right, thank you everyone for watching this video. If you have any feedback, if there is any special kind of changes that you would like to see for this dangerous AI agent, please let me know. Thank you so much for watching this, and I'll see you guys in the next video.